Hello everyone. Today we will see laboratory preparation methods of alkane. There are several methods. First is a hydrogenation. Second, hydrolysis of Grignard reagent. Third, reduction of alkyl halide. Fourth, Wood's reaction. And fifth is a Kolbe synthesis of alkane. These are the five methods to prepare alkanes. First method we will see hydrogenation. Hydrogenation means that is addition of H2. Now we will see what is mean by hydrogenation. Alkanes on catalytic reduction gives alkane. Alkenes on catalytic reduction gives what? Alkane. Now we will see what are the catalysts. So catalysts are H2 platinum or H2 ranil nickel or H2 PDC, that is H2 palladium, or A C means a charcoal powder. Now we will see examples. Now first example is now alkene, that is ethene. Ethene on catalytic reduction gives what? Alkane. Now ethene on catalytic reduction in presence of H2 and platinum gives what? We will see here what is the product. So now when we break this carbon carbon double bond, then valency of these two carbon will be free. So what is the valency of carbon? The valency of carbon is 4. When we break this carbon carbon double bond, therefore each of the carbon will gets a 3 valency, that is 3 bonds are there. So after breaking the carbon carbon double bond, just we have to add hydrogen atoms. Here hydrogen H2 gas, here it is a H2, that is we have to break this also a H2 gas, that is when we are breaking the valency will gets a free. Then after that what happens here, just we have to add a hydrogen gas across the double bond. So add hydrogen to this side, also add hydrogen atom to this side. Therefore what will happen, what was the valency of this carbon actual? So it was a 4 valency. It was also a 4 valency. When we break it will becomes a 3 valency. Therefore when after that we have to just add a hydrogen gas across the double bond. Therefore we will add hydrogen here and also we will add hydrogen atom here. So therefore what is the product? What will be the product here? Now this hydrogen, now look at this carbon atom. It has a already 2 hydrogen atoms. Also this carbon already have a 2 hydrogen atoms. Now when it gets one more hydrogen atom, then for what is the product here? CH2 will become CH3, and also here CH2 will becomes a CH3. Therefore what is the product? So write down the product. Good. What it will be? It is ethane. Good. So next example we will see here. Just remember that we have to add, just first of all break the bond, break the carbon carbon double bond and add hydrogen atoms across the double bond. Okay. Now next example we will see here. So pause the video and try to find the answer of this alkane. So what is the product? Just what we have already seen, that we have to break the double bond and just we have to add a hydrogen atoms. So what is the product? Just we have to break this bond and here take a hydrogen atom. Also we will take this H2. Now we have to break this hydrogen. Now it has also a one electron. When we are breaking this double bond, the valency get free. So just add here a hydrogen atom and also the hydrogen atom will add here. So what is the product? So see here CH3 remains as it is. Now CH, we are breaking this double bond. Now there is a single bond. Now CH, and already there is a hydrogen atom and also it is taking one more hydrogen atoms. Therefore CH will become CH2 and single bond. So CH2 will becomes what? After taking this proton, it will becomes a CH3. So good. What is the product here? CH3, CH2 and carbon carbon single bond and it is CH3. Therefore, what would be the product? The product is what? Yes, propane. What is the product here? It is a propane. Very good. So next example we will see here. So it is what? It is a cyclohexene. It is what? Cyclohexene. So we don't need to see this part. Just we have to focus on the carbon carbon double bond. So as like that we have seen already in a ethene and in a propene. Just we have to break this double bond. Now we have to add here hydrogen atom and also a hydrogen atom. Therefore, what? Just add a hydrogen atom across the carbon-carbon double bond. Here, that is break this bond and add here hydrogen atom. Also, the hydrogen atom will add here, and we have to break this bond. Therefore, what will happen? So, here a carbon-carbon single bond, hydrogen here and hydrogen here. Therefore, we can write this product in presence of, that is cyclohexene on treatment with what? H2PDC. It will give a cyclohexane. It can be written as like this, that is just simple a cyclohexane ring. So for the reduction purpose we can choose only one catalyst among the three reducing agent. Either you can choose H2PT, either you can choose a H2 in ranil nickel, or you can choose a, that is H2PDC. Yes. Now there are questions, that is how will you prepare, ethane? How will you prepare ethane from ethene? The questions are like that in the examination. Or how will you prepare propane from propane? What they will give? How will you prepare what? Propane from, they will told you that that is from the propane. So what we have to write? We have to write this structure and just we have to or take one of the catalyst among these three and just write the product. Yes, that's all. Next preparation methods we will see here. Alkane, we have seen just a preparation of alkane by the hydrogenation method. So we can prepare alkane from hydrolysis of Grignard reagent. Now alkyl halide on treatment with magnesium metal. Alkyl halide on treatment with magnesium metal in presence of dry ether. In presence of dry ether gives Grignard reagent, which on hydrolysis, to give what? To give alkane. So we will see the examples. So this is the general reaction for the preparation of alkane from the alkyl halide. Now alkyl halide is what? That is alkyl halide Rx on treatment with magnesium metal in presence of dry ether gives Grignard reagent. This is the Grignard reagent. Now here just we have to alkyl halide on treatment with magnesium metal in presence of dry ether. Just we have to insert this magnesium metal in this bond. So therefore, what is the product here? That is RMGX. RMGX. Good. RMGX. Now, this Grignard reagent on hydrolysis gives what? Alkane. Now, just what? R minus will takes a proton from what? From water, that is H2O. Then at the same time the hydroxyl group will be removed from the reaction. So what is the product here? Now this X is replaced by H. This X, that is this X is replaced by here a H, that is alkyl halide is converted into alkane. Now uh, after now what is the remaining here? It will take a proton from the uh, that is Grignard reagent will take a proton from water. Therefore what is the remaining? Mgx as it is. Now here we have added a hydrogen atom and it will become Mg. Whatever the hydroxyl group is removed, it will be along with the magnesium, that is MgXOH. Now next to see its example. Now methyl chloride on treatment with magnesium in presence of dry ether, it will gives a, that is Grignard reagent. It will give Grignard reagent. Same thing, just we have to insert this magnesium here. So after that it will take, now this Grignard reagent will take proton from the that is after we hydrolyze the Grignard reagent, it will produce what? Alkane. Just it will abstract the proton from the water and it will become a, that is CH3 will become CH4. And what is the remaining? What is the remaining? Here it is magnesium Mg and here it is OH and the Cl as it is, that is Cl. It can be written as that is CH4. What is the product? It is a methane, that is methyl chloride on treatment with magnesium metal in presence of dry ether. It will gives a Grignard reagent which on hydrolysis gives what? Its corresponding methane as a product. Now, ethyl chloride, ethyl chloride on treatment with magnesium metal in presence of a dry ether gives a Grignard reagent. So same thing, just we have to add here a, just we have to add here a magnesium metal. It will produce a Grignard reagent. What it will give? It will produce a Grignard reagent. Now after hydrolysis of this, after hydrolysis of this Grignard reagent, it will produce what? Same thing, the negative charge will take a proton from the water molecule and the hydroxyl will group will be replaced here or removed. Then what happens here? It we can write as a C2 minus, it will becomes what? C2H5. So it will, what is the product after taking the proton from the water molecule? C2H6. Then what is the C2H6? We already know that it is a C2H6 means it is a, that is ethane. Yes, very good. So what is the byproduct? It is a byproduct is what? Byproduct is magnesium as it is, then it is a Cl as it is, therefore what it is? AOH. So this is the method, that is second method we have. In the first method we have seen that is we can prepare alkane from the by the reduction or by the simple addition hydrogenation method, and second is a hydrolysis of Grignard reagent. Next method we will see here, that is reduction of alkyl halide by the reduction of alkyl halide. In the previous slide, we have also seen that is alkyl halides. We have already prepared from the alkyl halide. Another method just from the Grignard reagent we have prepared alkane. But also we can prepare the same thing from the reduction or by the reduction of alkyl halides. Okay, now let's see alkyl halide. Alkyl halide on treatment with zinc or copper in presence of alcohol to give alkane. And then let's see the example. General reaction. Then Rx alkyl halide on treatment with what? Zinc or copper in presence of alcohol, that is C2H5OH, to give what? To give alkane. Now just also we have to replace this X by H in presence of what? In presence of these two uh, reagents. Therefore, what are the reagents? Zinc and copper and a ethyl alcohol. Let's see the reaction. Now there are here the steps will start from the ethyl alcohol first. That is ethyl alcohol on treatment with zinc and copper. Two molecules we have to take here, and it will produce what it is ethoxide. That is here C2H5O 2C2 C2H5O means here there are two protons are there, two H are there. Therefore, what when this bond will break, that is OH bond will break, what it will remain C2H5 C2H5O twice, C2H5O twice, and the zinc and copper metals will be attached here. Now, what is the byproduct here? It is a byproduct, that is H2. Therefore, H2 will be liberated here, and the liberated H2 gas is called as a nascent hydrogen. This nascent hydrogen is used for the reduction of that is reduction of alkyl halide. Alkyl halide on treatment with zinc or copper in presence of alcohol to give or to give alkane. Here the actual examples we will see. See the example. So methyl chloride, in the methyl chloride, just we have to replace this iodine by the hydrogen atom. So methyl, and there are two hydrogen atoms are there. Therefore, one of the hydrogen atoms will attach to the carbon atom, and one of the hydrogen atom will react with the iodine atom. Therefore, when we break this, and just we have to add here a hydrogen and hydrogen. Therefore, when we break this bond, the bond will Hi and CH3. What happens? CH3 H means it is a, sorry, it is what? It is not. It is a CH4, that is methane. It is a methane plus Hi plus Hi. So this is the example, that is methyl iodide on treatment with zinc copper in presence of ethyl alcohol. Ethyl alcohol will produce a nascent hydrogen, and nascent hydrogen will reduce this alkyl halide or methyl iodide to produce a methane, to produce what? Methane. Next example we will see here. Now also the same thing is, we have to replace this halogen atom or chlorine atom with hydrogen atom. Therefore, when we replace this chlorine by hydrogen atom, what is the product? C2H5 will be converted into C2H6. Also we can write this, that is C2H6 can be written CS3 and CS3. Therefore, what is the name of this compound is ethane. That is ethyl chloride on reduction with, on reduction gives what? On reduction gives ethane. So these are the three methods to prepare that is alkane. Uh, in the next video lecture, we will see the remaining two methods, that is Wool's reaction and a coal-based synthesis. Thank you.